In this video, we'll take a look at two-column proofs. A proof is a logical argument that shows a statement is true. There are several different forms of proof. We're going to take a look at two-column proofs, where we have statements on the left and reasons on the right. We number each statement and match it with each reason. Because we're making statements based on fact, we're using deductive reasoning. And the first statement and reason, the reason is usually the word given because the statement is the initial problem that you're starting with. So we have the statement 2AB equals AC. That's given. So two of these will be equal to all of this. So let's take a look at our first statement that we're going to add. We say that AC is equal to AB plus BC. This is your segment addition postulate. Again, 2AB is equal to AB plus BC. This is going to be your transitive property of equality. We go from this statement up here being A is equal to B. We say B is also equal to C. Therefore, A is equal to C. Next, I'm going to subtract 2ABs from both, not 2ABs, but 1AB from both sides of our equal sign. And we're down to this line of our proof. AB is equal to BC, and that's using your subtraction property of equality. It helps to sketch a graph and label it as often as you can. Can include definitions, properties, postulates, and theorems. Remember, theorems are statements that have been proven, and once we have a proven theorem, we can use it in other proofs. We're going to look at three congruence theorems that work for both angles and segments: reflexive, symmetric, and transitive. For segment and reflexive, we say for any segment AB, AB equals AB. If segment AB is congruent to CD, then CD is congruent to AB. That's an example of your symmetric congruence theorem. And transitive theorem, AB is congruent to CD, and CD is congruent to EF, then AB is congruent to EF. See if you can fill in for each of these theorems for angles. To take a look at the reflexive theorem and to show you the proof for that, we start off with our given statement, and we say AB is equal to AB. That's your reflexive property of equality. And we're going from equal to congruence, and that's using the definition of congruent segments. Similar for angles. As we look at the symmetric theorem of congruence, AB is congruent to CD, and we say AB equals CD. This is that definition of congruent segments. And we say CD is equal to AB. Notice we're just kind of flipping the order. That's your symmetric property of equality. And then we go from equals to congruence, definition of congruent segments. The angle theorem is similar. For the transitive theorem of congruence, we say that AB is congruent to CD and CD is congruent to EF. Now we're changing those from congruence to equals. That's your definition of congruent segments. And then this is the transitive property. A is equal to B and B is equal to C. Therefore, A is equal to C. Transitive property of equality. We go from equals to congruence. Definition of congruent segments. Take a look at the proof for angles. Now see if you can name that theorem. Transitive theorem of angle congruence. symmetric theorem of segment congruence, reflexive theorem of segment congruence, and symmetric theorem of angle congruence. Go ahead and take a look at a proof. We have AD is equal to 8. BC is also equal to 8. And we know that BC is congruent to CD. We start out with the given statements, and then we say AD equals BC. This looks like the transitive property of equality. We go from equal to congruence, which is the definition of congruent segments. Now, where did this statement come from? Oh, it came from right up here. This is a given statement. If BC is congruent to CD, therefore AD has to be congruent to CD. If we combine these three statements, this is also your transitive, but it's not a property of equality anymore because we have congruence going on. This is that transitive theorem of segment congruence. Complete the proof. AD is 12. AB is 12. BC is congruent to CD. And AD is congruent to CD. We have to prove that BC and AB are congruent. Looking at our proof, our first step is that transitive property of equality because of the equal sign. I go from equals to congruence. This is your definition of congruent segments. BC congruent to CD, AD congruent to CD. Where did that come from? Oh, that came from my given statements. If they're not all listed in that first line, be on the lookout for them to appear later in the proof. BC congruent to CD, CD congruent to AD, therefore BC is congruent to AD. And we have congruence. This is that transitive theorem of congruent segments. If BC is congruent to AD, and we know AD is congruent to AB, then BC is congruent to AB. Again, transitive theorem of segment congruence. Complete the proof. We have our given statements, and then we say the measure of CBD plus DBE equals the measure of CBE. So looking at your diagram, CBD plus DBE equals CBE. That's your angle addition postulate. Now we're just replacing the measure of the angles with the actual measurement. So that is your substitution property of equality. Next, I'm doing some algebra. I'm subtracting 50 degrees from both sides. So that's using your subtraction property of equality. Now we're saying that CBD is equal to the measure of DBE. This is your transitive property of equality. Up here we said the measure of CBD was 50, and 50 is the measure of DBD, therefore CBD is equal to DBE. Next, we're just rewriting that statement from equals to congruence, definition of congruent angles, and then we have that ABC is congruent to DBC. If we know that ABC is congruent to CBD and that CBD is congruent to DBE, therefore ABC is congruent to DBE. We've got the congruence. This is that transitive theorem of angle congruence. Our next proof, we have a bunch of given statements. And then we go from congruence to equals. This is your definition of congruent segments. AB is equal to BC. BC is equal to CD. Therefore, AB is equal to CD. And same for this next piece. That's your transitive property of equality. Next, we say the perimeter of this shape is equal to AB plus BC plus CD plus AD. That's your definition of perimeter. Remember, perimeter is the distance around the outside edge of your shape. Next, we're just abbreviating perimeter to say the perimeter of ABCD is equal to AB, 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 AB. We're replacing each one of these segments with AB. That's your substitution property of equality. Because remember up here, we said that each one of them is equal to AB. Next, I'm just simplifying, and that's the last step of my proof. If you could, you can take a look at this next example and explain your steps in a paragraph proof, where each step you'd have to justify with a reason. So we'll talk it through. We know that angle D is congruent to DEG. Angle D is congruent to DEG. So these are congruent. If we know that D is 4x, then we know that DEG is also 4x. Then we have EG bisects DEF. This is your bisector. Remember that a bisector is going to cut your angle into two equal pieces. Therefore, 4x and 2x plus 3 are equal. I can set that up and solve for x. As I solve for x, I am subtracting 2x. Then I'm using the division property of equality. Take a look at it explained in a paragraph.